Okay, welcome to this video on trig equations. We're going to show you how to solve trig equations and how many solutions they have over 360, things like that. So, first thing we have to know is we have to remember the three graphs that we've got: sine, cos and tan. I expect you to be fully conversant with these shapes of graphs and all the key points about it. Okay. Remember, sine, cos and tan are circular functions going round a unity circle, and we're going to relate these three graphs to going round the circle on the right hand side. We're going to help that to solve equations for us. So, if we look at the sine graph, we can see it's positive from 0 to 90 and 90 to 180. So what we can say in here, from 0 to 90, sine's positive, and it's positive between 90 and 180. For the cos graph, if we look at the cos graph, it's positive 0 to 90, so cos is positive in here, and it's not positive in the second or the third quadrant, it's positive in the fourth quadrant, this part here, that's between 270 and 360, so cos is positive in there. And if we look at the tan graph, it's positive from 0 to 90 again, so positive in here, and it's negative in the second quadrant, but it's positive in the third quadrant, that's between 180 and 270, so it's positive in here, and it's negative in the final bit there. So this is us got the three graphs where they're positive and negative related to this side over here. Now they're all positive in the first quadrant, so rather than saying SCT, I'm going to take that out, and I'm just going to say they're all positive in the first quadrant from 0 to 90. And some people call this a cast diagram, cast, makes the word cast, but remember the C starts in the fourth quadrant and we write cast going that way. So that helps us to remember that all the graphs are positive in the first quadrant, sine's positive in the second quadrant, tan's positive in the third quadrant, and cos is positive in the fourth quadrant. Now that means if sine is positive in the first and the second, then if we look at the graph here, it's negative in the third and fourth, but we don't write that in, we know if the S is not in the quadrant here, then we know it's negative. Same idea with the tan. The tan's positive in the first and the third, and it's negative in the second and the fourth, so that's the second and the fourth. The T's not in there, so we know it's tan's negative in there. I've seen that idea with cos. Cos is positive in the first and the fourth quadrant, that's in here and in here, and because the C's not in these two, it's negative in there. And that's going to help us to solve trig equations. Now, in your when you're using your calculator, you always work out the positive value in here, always, and then we can translate it into the quadrants that we need, depending on the question. Okay, so if we always call x the value, the principal value between 0 and 90, that's the one we always work, that's the one your calculator can work out, no problem. And then we use this diagram here to work out any other quadrants that we need. And to work out the second quadrant, it's 180 minus x degrees, and 180 plus x degrees in the third quadrant, and 360 minus x in the fourth quadrant. I'm just going to call that Q4 for fourth quadrant, Q3 for third quadrant, put a wee bracket around it so we can see it, Q2 second quadrant, and the first quadrant, the principal value we call that in the first quadrant, because they're all positive in there. So let's look at a reasonably straightforward equation. So we'll have something like 7 sine x plus 2 is equal to 3. And we have to find the values. I haven't put the range in, but the range is between 0 and 360. Okay, so what is it we're actually trying to do there? Well, let's rearrange it into sine x equals. So from first year work, we'll subtract 2 from both sides. So that gives me 7 sine x is equal to 1. And then we'll divide through by 7. We divide through by 7, that's a seventh. Now, at that point there, there's a couple of ways you can relate it to what you want. You can either use the graph version of it, and we want to know when sine x is equal to a seventh. Now a seventh is very small, okay, about 0.1, 0.2, so it's in here and it's positive. So we're looking for two values, one in the first quadrant and one in the second quadrant, because this value is positive. So relating it to this side, we're looking for values when sine's in here and in here. Now that's your first and second quadrant. I think I'll just use a different pen here just to highlight this. So we're ticking here and here. So let's solve it. Well, solving it, using our cast diagram up here, then we have, to get rid of sine, we do shift sign on our calculator, so shift sign in your calculator, and we're looking for the value on the calculator of shift sign of a seventh. And if you put that into your calculator to one decimal place, you'll get a value of 8 degrees. So that's one of our values. It's one of our values because it's in the first quadrant and this value is positive. So I'll just put Q1 beside that to say that's our quadrant 1 value. Another value that we need is in quadrant 2. Now quadrant 2, over the right hand side here, tells us if we take the principal value was at 8.2 and we put it into the second quadrant, we have to do 180 minus that 8.2, and that's 180 minus 8.2, and our value for that is 171.8 degrees. Okay, and that's quadrant 2. That's all there is to it. Now, in your exam, that's worth about 3 marks in your exam. Okay, so let's look at another question. We'll involve cos this time, I think. So just rub this one out and we'll look at cos. So we'll just rub out the cast diagram, reset it, and let's go for let's see, something like 3 cos x minus 1 equal to 0. Again, the range is over 0 to 360, over a full circle. So again, back to first year, let's solve the equation down to cos x equals. So we add 1 to both sides. So that leaves me 3 cos x then is equal to 1. And then we're going to divide through by 3. So cos x then is equal to a third. Okay. Again, we look at our cast diagram, and that tells us that we're looking for a value in the first quadrant because it's positive again, they're all positive in there. And cos is positive in the fourth quadrant, so we're looking for a value in there. So we substitute that into our calculator, we rearrange it to have x is equal to shift cos a third, and we're putting this into our calculator. So shift cos a third, close bracket, and press equals. And this is the first quadrant value that we're working out. So when you put that into your calculator, you should get an answer of 70.5 degrees to one decimal place. And this time we're looking for the fourth quadrant because cos is positive in the fourth quadrant. It's not the second, it's the fourth this time because it's cos. Quadrant 4. So what do we do for quadrant 4? Well, quadrant 4 tells us we take the principal value and we take it away from 360. So 360 minus 70.5, and again bump that into our calculator to one decimal place, 289.5 degrees. So there's our two values. Okay, again 3 marks in your exam. Let's see if I've got any other ones that are reasonable. Here's another one. Let's go for another cos one. And let's go for 11 cos x minus 2 to 3. And again it's over 0 to 360. You maybe want to pause the video and maybe have a wee go yourself and then play the video and see if you get the right answer. So first of all we rearrange it into cos x equals, so add 2 to both sides. So that leaves me 11 cos x then is equal to 5, and then we're dividing through by 11, and we're left with cos x then is equal to 5 over 11. Again, it's a positive value, so positive value, when's cos positive? It's in the first and the fourth quadrant. So it's these two quadrants we're looking for again. So shift cos in your calculator, so this is how we write it down, and the buttons you press, shift, cos, 5 over 11, close back, equals. Now again, first quadrant again, so right, first quadrant, so x is equal to, and if we work that through in your calculator, you should get an answer to a nearest whole number is 63 degrees. And we're looking for the fourth quadrant, so fourth quadrant is telling us to the principal value away from 360, so x is equal to 360 minus 63, and we've got an answer of 297 degrees. Okay. Now we do get harder ones in the exam in terms of context questions, but I think I'll leave that to another video. We won't do that one just now. Okay, so that's all that's involved, isn't it? Maybe do one that's negative, I think, and maybe pick tan this time. So let's look at a tan one. Let's make it tan x minus 2 is equal to 0. So let's look for that one there. Just reset my cast diagram. So rearrange it into tan x. So adding 2 to both sides, we're left with tan x is equal to 2. That's me just adding 2 to both sides. So when does tan x equal 2? Well, for tan, 2 would be up here somewhere, and if we put a line across there, it would be the first quadrant, and it would be the fourth quadrant when it's positive. That's equivalent to first quadrant here, third quadrant here. So let's work it out. So shift tan in my calculator. So write down working for that, and then we plug that into our calculator. So it's going to be the first quadrant. So x is going to be equal to, now if you put that into your calculator, that'll be 63.4 to one decimal place. And we're now looking for quadrant 3 this time, that's where tan's positive here. So let's do x is equal to 180, and we add on the principal value here, because we want it in the third quadrant. And if we do that, that's going to be 243.4 degrees. And that's a tan one done for you. Now if you notice that all these ones were positive, so let's try one that's negative. It's going to turn out to be a negative type value. So I'll go back to sine, and let's go for something like 2 sine x plus 1 is equal to 0. So we have to solve that equation. So rearranging it again, taking 1 away from both sides, so we're beginning to solve it. That's 2 sine x is equal to -1, and then we're going to divide through by 2. So we've got sine x then is equal to -1/2. So when does sine x equal a value of -1/2? Well, -1/2 is in here, below the x-axis there, so or the horizontal axis. So we're looking in the third quadrant and the fourth quadrant here. This is where -1/2 is going to be. It's going to be halfway between 0 and -1. So we can see the value is going to be in a bit here. To look at the cast diagram, well, with the cast diagram, sine's negative, it'll be in the third quadrant and the fourth quadrant because it's positive in there. So it's these values we're looking for. Now, the negative sign indicates which part of the quadrant we're talking about here. Okay, the third and fourth. We always work out the principal value. Now the principal value is always Q1. Now you've got to be careful here. So we're actually going to work out the principal value, which is always positive, so we'll only take a half here. The negative indicates the quadrant. We only work with the actual number value, which is a half. So solving that in quadrant 1, well, that's going to be x is equal to shift sign of a half. Now we don't need a calculator for this, or you shouldn't need a calculator. We expect you to know this from your exact value table. Shift sign of a half, you should know that that is 30 degrees. But that's not the value we want. We're wanting the third and the fourth quadrant. So the actual values we want, Q3, well, the x value that we want is 180 plus 30, which is 210. That's one of our values. And we also want the fourth quadrant because we're looking for the negative value, remember, the actual question's the negative a half. So that's going to be 360 minus 30 degrees. That comes from here in the cast diagram up here on the right hand side. And that's going to give me 330 degrees. Okay, so that's your two values here. Maybe just box them, just so you know that's the values that we're actually talking about that we need to solve the equation. Okay, right, let's go for one more. I'll do one more and I'll make sure that it's negative. I think I'll just pick cos this time. So let's go for 2 cos x plus root 3 equal to 0. So we've got to solve that equation. Well, take away root 3 from both sides, so we're going to subtract root 3 from both sides. So I'm left with 2 cos x is equal to negative root 3. Divide through by 2. So cos x then is equal to negative root 3 over 2. So when is the cos graph equal to negative root 3 over 2? Well, that's going to be underneath the x-axis, and if we think about what root 3 over 2 is, well, it's going to be less than, it's going to be somewhere between 0 and minus 1. So we're going to have a value in the second quadrant and the third quadrant. Why is that? Because if we look at our cast diagram, get rid of these, this is the question we're doing here. Where is cos negative? It's negative in the third quadrant and the second quadrant. So second and third quadrant, that's the two values that we're actually looking for. So remember, we always work out the principal value. We always work out this value in here. So let's put down Q1, and what we actually want to solve for Q1 is the positive value, root 3 over 2. So shift cos in your calculator, root 3 over 2. Again, don't really need a calculator for this. If you know your exact value tables, you should know that that value again is 30 degrees for cos. And that's the value in Q1, but that's not what we want. So we've got this one, we need it in here and in here. So we're really looking for Q2. So x is actually equal to 180 minus 30, which is 150. So that's one of our answers. And then our other answers in Q3, well, that's going to be 180 plus 30 degrees, which is 210. And that's our second answer there. Okay, I think I've done enough for them. 3 marks in your exam, well worth trying to learn this, especially if you're going to do higher, because you're going to do harder trig equations at higher. And if you know this topic inside out, it will save you a lot of grief at higher, because pupils who tend to do higher from National 5 haven't done a lot of trig work, or they can't remember a lot of the trig work, because it tends to come up towards the end of the course, so they don't really know it that well, and that causes issues for them higher. So if you can get on top of this now, then your higher work will be vastly improved and made easier for you because you know this stuff already. Okay, so that's